Greetings, geometers. 4-3. Let's talk about that a little bit. Here you get introduced to two new congruence postulates in this book. ASA and SAS stands for angle side angle and side angle side. Most geometry books have these as theorems, but Mr. Jacobs has chosen to just present them as postulates, so we'll accept them without having to prove them. All right, so the ASA postulate, angle side angle. All right, here's what this means. Let's say I've got two triangles, and let's say that, and I know I just hand drew them so they're not looking very congruent, but let's say that they are, that we know this about them. This is triangle ABC and triangle DEF. We know that, let's say we know that this angle is equal to that angle, and this side is equal to that side, and this angle is equal to that angle. All right. If we know these three critical things about the six main pieces of the triangle, that is the three angles and the three sides. Okay. So if we know that two angles and their included side are equal to two angles and the included side of another triangle that are corresponding to it, then we have enough information to know that we have congruent triangles. So we don't have to go through and say try and prove that all six of those, the three angles and the three sides, are equal to each other, because if you think about it, angle side angle, if these angles are established here, then that's going to determine that the third angles have to be equal, because they all have to add up to 180, right? And then the two side lengths are also set by the fact that these two angles are determined here. And so that's going to mean that the side lengths are going to be, we know what their length is going to be just from knowing the two angles there and their included side. Okay, so here it is, the ASA postulate. If two angles in the included side of one triangle are equal to two angles in the included side of another triangle, the triangles are congruent. So we could say here triangle ABC is congruent to triangle DEF. So we can make a congruent statement from that. All right, so that's one of them. So what does it mean to be the included side? That means that the angles are at the end points of that side. So it's like the side is in between those two angles. That's the included side. All right, so that's one of them, ASA, angle side angle. We also have another situation. So let's say we have a couple of triangles. Let's get this out here so we can see what we've got. All right, so we have these two triangles, and you'll see that it's worded very much the same. And I know they don't look congruent, but we'll just pretend that they are. Okay, so if two sides in the included angle of one triangle are equal to two sides in the included angle of another triangle, the triangles are congruent. All right, so what do we mean here? Two sides in the included angle. So let's say I know that this side and that side are equal. This side and this side are equal. And this angle equals that angle. Well, you can see that the other two angles in the other side have to be already predetermined. Then so AC's got to be equal to DF, and angle A has to be equal to angle D, and angle C has to be equal to angle F. So again, rather than having to prove that all three angles and all three sides are congruent, equal to each other, and therefore the triangles are congruent, if I have the right three of those six, I can make that conclusion. And that's what ASA and SAS are saying. If we have them set up in this relationship, that two sides and the included angle. So what's the included angle? The same thing with the included side. It's the angle that the two sides create. This angle here has as its the sides of that angle AB and BC. Alright, so if I have two sides and their included angle are equal to two sides and the included angle of another triangle, then we can say triangle ABC is congruent to triangle DEF. And we said that up here. Up here it was by the ASA postulate. Down here it's congruent, they're congruent by SAS postulate. So you can tell from the way they're marked. Notice that we use crescents to mark equal angles. So a single crescent for the first pair, double crescent for the second pair. If we did a third pair, that would be 3 crescents. And the same thing with tick marks on the sides. AB and DE each have one single tick mark, and there are 2 tick marks for BC and EF to indicate that they're equal to each other in length. Alright, so looking at the diagram below, here's 2 triangles. Is this ASA or SAS congruence? Look at the way it's marked. Okay, you can see that there are 2 sides, one side of one and one side of the other, and that's the included side between these 2 angles that are also marked equal to each other. A equals D and B equals E. So angle, side, angle. So we would say these triangles are congruent by ASA, angle, side, angle. And that's the lesson.